Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zahir Sam bin Muhammad Zahir and my metric number is 10DJL22F1011. So today I'm going to talking about the valve timing chain. So here we have a valve timing diagram. So what is a valve timing diagram? A valve timing diagram serve as a visual description that illustrates the precise moment when the intake and exhaust valve of any engine open and close. The timing of this valve action is intricately tied to the movement of the piston as it travels from the top dead center DDC to the bottom dead center BDC within the combustion chamber. So here we have a theoretical process of a valve timing diagram of four-stroke engine. So at the suction stroke, the engine cycles commence with the suction stroke, where the piston located at the top dead center DDC move towards the bottom dead center BDC, causing the inlet valve to open. This motion allows the air-fuel mixture for petrol engines or fresh air for diesel engines to enter the cylinder until the piston reaches BDC. At the compression stroke, where the piston moves from BDC to DC, compressing the air-fuel mixture petrol engine or fresh air diesel engine. This compression raises the pressure inside the cylinder, preparing for efficient fuel combustion. During this process, the inlet valve closes to seal the chamber for effective compression. So now is the expansion stroke. The expansion stroke follows ignite by the combustion of the fuel. The combustion pushes the piston located at the TDC towards BDC, releasing the pressure generated by combustion and generate output power. It is important to note that in petrol engines, combustion occurs due to the spark produced by the spark plug, while in diesel engines, combustion happens due to high compression provided during the compression stroke, raising the temperature inside the cylinder to the outer ignition temperature of the diesel engine and air charge. In petrol engines, the air-fuel mixture enters the cylinder during the suction stroke, whereas in diesel engine, fresh air enters during the stroke, with fuel being sprayed by fuel injected into the air. And now exhaust stroke. Finally, the exhaust stroke takes place. After the expansion stroke, the piston located BDC moves towards TDC, and the exhaust valve open to remove the residual combustion gases from the cylinder. The exhaust valve closes once the piston reaches TDC, completing the four-stroke engine cycle. So we have a valve timing diagram of four-stroke petrol engine and diesel engine of actual process in valve timing diagram. So as you can see, it is much different from the theoretical valve timing diagram. So during the suction stroke of a four-stroke engine, the inlet valve open at approximately 10 to 20 degree in advance of the top dead center TDC. This timing allows for proper intake air-fuel mixture petrol or air diesel, while also facilitating the cleansing of any remaining combustion residue within the combustion chamber. The compression stroke began as the piston reached the bottom dead center BDC. The piston then starts moving towards the TDC, and during this compression stroke, the inlet valve closes at approximately 25 to 30 degrees past BDC. This closure ensures complete sealing of the combustion chamber, enabling effective compression of the air-fuel mixture petrol engine or air diesel engine. Within the compression stroke, as the piston progresses towards TDC, fuel combustion occurs roughly 20 to 35 degrees before reaching TDC. This timing ensures proper fuel combustion and optimal propagation of the flame. Following combustion, the expansion stroke commences. This stroke is initiated by the release of pressure inside the combustion chamber due to the full combustion, resulting in the rotation of the crankshaft. The piston moves toward TDC to the BDC during the expansion stroke, spinning approximately 30 to 50 degrees before BDC. To begin the exhaust stroke, the exhaust valve open approximately 30 to 50 degrees before BDC. This enables the expulsion of the combustion residuals as the piston moves from BDC to the TDC. The exhaust stroke continues until roughly 10 to 20 degrees after piston reach TDC. So now we at the part of apparatus and equipment involved timing chain practice. So number one is which is the obvious one, the 4-stroke petrol engine, and number two a degree wheel and pointer, dial indicator 10 mm at both which is the intake and exhaust valves, dial indicator holder which is a holder for the dial indicator, degree wheel adapter, and 90 mm command ring span. So the procedure of the valve timing chain practice, which is number one, make sure the dial gauge meter at intake and exhaust valve point at 0. Make sure number second is make sure the piston at top dead center TDC and pointer degree wheel is at 0 degree TDC. And number 3 is turn the degree wheel counterclockwise until the exhaust meter move one round per 1 mm. Then take a degree point at degree wheel stop for the exhaust open. Number 4 is next, continue turn to the degree wheel counterclockwise until the exhaust valve fully open. Take measure exhaust valve lift with dial gauge meter. Number 5 is continue turn the degree wheel counterclockwise until the dial indicator meter move 1 revolution per 1 mm. Then take the degree for open intake valves. Next, continue turn to the degree wheel counterclockwise until the intake valve fully open. Take measure intake valve lift with the dial indicator meter. Continue turn the degree wheel counterclockwise until the exhaust valve dial indicator back to 0 mm. And then turn back clockwise direction until exhaust dial indicator meter stop at 1 mm. Take a degree value at degree wheel. And lastly, turn back the degree wheel counterclockwise direction until the intake dial indicator meter back to 0 mm. Turn back degree wheel at clockwise 1 mm. Take angle point at the degree wheel.